Hello everyone and welcome to this ChemNet webinar. My name is Gareth. Some of you may recognize me from the ChemNet website and I look after ChemNet here at the Royal Society of Chemistry. First of all, we want today's session to be interactive, so please ask me any questions throughout the presentation by typing them into the box on the screen. And if you have access to a microphone, please let us know as we're able to unmute you and we can have a chat with you that way. Through the session we'll also have some interactive polls and they'll appear on your screen, so keep an eye out for those as well. Now I won't be delivering the main part of the session, but I wanted to introduce you to some of the newer functions on ChemNet that we've uploaded recently and some that will help you as you're doing your revision over the next few weeks. So hopefully most of you will recognize that this is the ChemNet website and this is your dashboard. On here you can find out what's been going on recently. On the right hand side you can find the recent discussions and usually some announcements telling you the new things on the website. But we know most of you come to the website to come to the discussions. You've always got some fantastic burning questions for Dr. ChemNet and Dr. Careers. Both of those will answer your questions on your practicals, anything you're revising, homeworks, or Dr. Careers will help you with how to get into the career you want and help you identify any skills you've already got to get there. Many of you also use the general forum. I've seen you talk about eclipses, EPQs, and goodness knows what else. And it's really great to see you helping each other on your homework too. Another thing I want to highlight today is our events. Now if you haven't already been to a ChemNet event, why not? As you can see by our map, we've got some up and down the country, whether it's a revision workshop, a lab session, or getting to speak to a real-life chemist. They're a great opportunity for you to find out more about chemistry. One of our biggest events that we hold each year is Meet the Universities. This year we've got one in London and one in Sheffield. It's an opportunity for you to meet the admissions tutors to each of the universities across the UK. And this year, for the first time ever, we'll have Dr. Careers there who'll be able to help you make those all-important decisions. I'm sure many of you are already working hard and revising for your exams coming up. Or if you want a little break, we also have our monthly competition. It's usually a short science-related questionnaire. Most of you do really well. Oh, that's not quite working, is it? But I'm sure many of you have already seen it. As well as our monthly competition, we highlight the Bill Bryson competition, the Google Science Fair, and many others for those of you who really want to challenge yourself. Another big part of ChemNet is our study help and our Your Future section. Here we collect resources that are from all over the internet which can help you with your studies. Some can help you find work experience. Some are just handy to know, some are fun to watch. If there's any that you found that we haven't already started advertising, let us know and we'd be more than happy to put them up onto the website. The Mole is also another benefit of being a ChemNet member. This is your online magazine and we bring you articles from the cutting edge of chemistry, opinion polls, puzzles, and other career profiles. Make sure you have a read every other month when we put it online for you. Finally, we know lots of you keep an eye on the leaderboard. This is where you can find out if you're a top contributor, find out who is on top of the leaderboard, and of course how many points that you have. If you go to your profile, you can see what badge you are, and if you're at our top badge, you'll get a certificate on its way to you. Now I'd like to introduce Steph Musson. She's one of our education executives here at the Royal Society of Chemistry. Steph's a chemist with an MSci in chemistry from the University of Glasgow. She's also an ex-teacher, and she knows exactly what she's talking about when it comes to using technology to support your studies. So over to you, Steph.
Okay, thank you, Gareth. I'm just going to shuffle onto the camera now. Okay. Right, are we sharing webcam? Okay. So I'm going to talk to you about using the web to help you with your chemistry studies. Some of you are maybe already doing this, but some of you are maybe thinking that it would be a really useful resource. So hopefully we can tell you a bit more about it today and a bit more about our resources to help you get started. Okay, so let's move on. So just I'll outline to you what we're going to cover in the rest of the session. So like Gareth mentioned, we're going to do some quick polls. So we want to find out a bit about you, and that's so that we can tailor this session for the people that are here and listening. And also we want to have a look at some of the resources that you use. Some of you have already been on ChemNet and talking a bit about that, and we want to encourage you to keep that conversation going on ChemNet after this webinar as well. Okay, we're then going to think about the pros and cons of online resources and look at some of our resources on Learn Chemistry, and then at the end we want to hear some of your thoughts. So this is just a bit of a heads up to you all, that at the end we'd really like it if some of you would come on the microphone and you would speak to us, tell us your thoughts on the resources that we've shown you, the pros and cons like we've discussed, and also maybe if you want to tell us a bit about some other resources that you use that you think are great and you want to share with other people. Okay. So we're going to start off with some polls. So first of all, we want to find out whereabouts you are. So the first question, I'm just going to bring it up now, okay, is where are you? So you can select one of these. Are you in Scotland, England, Ireland, Wales, or are you somewhere else more exciting and exotic? Okay, so lots of you responding just now. Okay, it's going to give you a little moment more to complete that poll. Okay, I think we've got everyone now. We're going to close the poll and I'm just going to show you the results. Okay, so we have most of you here in England, but some of you elsewhere as well in the rest of the world. We've got a few people in Scotland. You might be able to tell from my accent, that's where I'm from originally, and some from Wales, Gareth, as well. So we've got a nice representation there. Okay, those of you in the rest of the world, maybe you can tell us using the comment box whereabouts you are and we can have a look at that for interest. Okay, the next poll, the next question we're going to ask you is what age you are, and this is so we can tailor the resources we're going to show you. So you've got some different options here. So are you age 13 to 14, 15 to 16, 17 to 18, or are you over 18? Okay, so lots of people responding just now. Just give you a little moment longer to get your answer into that one. Okay, I think that's everyone. We're going to close the poll now and show you the results. Okay, so everyone then is between 15 and 18, so we'll keep it to our sort of more sort of higher level resources then for you guys. Okay, that helps us. So then the last poll we want to ask you before we get started then is just to find out a bit about how confident you are already at using online resources. Okay, so how confident are you at finding and using online resources? Are you very confident, confident, a bit confident, or not confident? So select one. Okay, there's lots of you responding there. Okay, yep, I'm just going to close the poll. We've got everyone responded now. Okay, and show you the results there. Okay, so yeah, most of you sort of in the middle there. Hopefully by the end of this webinar you'll be feeling a bit more confident, but we'll see. We're going to ask you the question again at the end. Okay, so if we come back to the PowerPoint now. Okay, great. Okay, so like I said, I wanted to have a little look at some of the resources you've been looking at yourselves. So someone mentioned YouTube. Yeah. We have a YouTube channel. YouTube is an excellent way of finding things out, watching videos on there is an excellent resource. Just that one, that's something someone's mentioned, a good app, and you can make it specific course that you're studying. Recommendation as well. Someone talking about BBC Bite Size, yeah, and Chem Guide for further reading. And interactive simulations, something that well, we've got Nicole there mentioning that they're really useful for helping to learn about chemistry. Okay, so there's a conversation like we said on ChemNet, so you guys can go and visit that, and what would be really great is if you keep adding to that, and when you find other resources you can add them on there, share them with people, and then you'll have a nice library of resources to help you there with your studies. Okay, so like I said, we're going to have a little look at the pros and cons of using online resources. So there's ease of access. Now, I haven't necessarily put this in a pro or a con because I think it could go either way. In one way, it's easier to access online resources. You don't have to go to a library, check out a book, or remember to bring some physical resource back with you from school. so it can be easier in that sense. You just get online, find what you want. But that can also go the opposite way as well. If your internet isn't working or your computer isn't running as fast as maybe it needs to, or maybe the resource that you like to use is in a format that doesn't work well with the type of laptop or device that you're trying to use to access it. So that can have pros and cons sides to that access issue there. There are a lot of resources available online. If you go to Google and you search for something, I'm sure you would find lots of resources. Say you look for conservation of mass, you'll find a lot of stuff on there that can help you. So there's a huge amount of resources available for you. But then the flip side to that is not all of them are from reliable sources, so how do you know if you can trust them? Are they telling you the right chemistry, or is that maybe a little bit wrong? So there's sometimes a bit of a question there. So it's really important that when you're using online resources, you make sure that where you're getting them from is a reliable source. Digital resources can provide really great opportunities to help you explore a concept. So on the ChemNet forum someone mentioned interactive simulations. So they give you a chance to play around with different aspects of a particular practical, for example, or maybe to look at a concept in a way that you couldn't look at it physically in real life. And also animations and videos, they can be used to illustrate a concept that might be quite abstract and difficult to explain in words, but visually it can be illustrated very clearly, so they can also provide that benefit as well. But all of this is only really important if the resources help to improve your knowledge or your understanding. I think there are a lot of resources online which perhaps you can use, but maybe they're not necessarily moving your knowledge or your understanding forward. So whatever you're using, whether it's a book or an online resource, an animation or video, it's important to question whether or not it's actually useful for you, and whether it's doing what you need it to do. Is it meeting your need? Is it moving your understanding forward? Don't waste your time on stuff that is just a game or is just rote learning. You should be focusing on knowledge and understanding. Okay, here we go. Okay, so we've covered the first three things then. We've done our quick polls, we've looked at resources that you use, we've looked at the pros and cons. What I'm going to focus on now is showcasing some of our resources. Now what I should say is these resources are available online in chemistry. They are completely free to use. I will be putting the links up at the end so you'll be able to find them, but if you forget what those links are, if you forget how to get there, you can just go to Learn Chemistry and you can search for resources on there and find them. And like I said, they're completely free. Once I've done that, I'm going to ask some of you to come on to the microphone and to talk to us about your thoughts. So if you would be confident in doing that or happy to do that, what I would really like is if you comment in your comment box, in the chat box, and let us know that you would like to come on the microphone. So just make sure you have the right setup, and if you do and you want to, let us know and we'll get you on towards the end of the webinar and hear from you as well. Okay, so I'm going to come out of the PowerPoint now. So most of you are a bit older, so I'm going to focus what I'm going to talk about now on some of our higher level resources. So this is the Learn Chemistry website here. So this is where you would start off from, and you can search for whatever it is you're learning about, whether that's concentration, or it's, like I mentioned before, conservation of mass, or it's calculation problems. You can search in here and you can find resources for you. But I'm going to speak about some specific ones here. Okay, so you might have already seen PhET resources. So PhET are an organisation based at the University of Colorado in Boulder in the US, and we collaborated with them to make a whole range of chemistry simulations. So you can see all of them here. But PhET on their website have a lot more resources as well. They have a lot of physics resources, so there's a huge amount on there to help you with your studies. So I'm going to look at the acid-base one, which is, click in here. So this one here is looking at pH, and it's looking at the strength of an acid and dissociation. Okay, so the acid-base simulation can help you to explore your understanding of acid-base strength in relation to the extent that it dissociates in water. You can identify all the molecules and ions present in an acid-base solution, amongst lots of other things on this simulation. So this is an example of a resource that helps you to explore a concept. So we're going to pop the pH probe in, And you can see that this is pH 7 here. Okay, so you've got some water and it's dissociating into these two ions here. And you can see the ions under the microscope here. You can see them in colour. Now, you can play around with this. You can say, okay, instead of just looking at water, I want to look at a strong acid, or I want to look at a weak acid. You can see in the weak acid there's less dissociation. Or I want to look at a strong base, or I want to look at a weak base. Okay, so you can look at these different things. So if we go back to, let's have a look at a weak acid. So you can see there you've got your different molecules showing up underneath the microscope here. Now what I can do as well is I can make it show me the solvent molecules. So you might think, well, hang on a minute, isn't an acid something that's solid but it's in solution, and that's what gives us this here, so we can show the solvent. So what we've just done is we've taken them out to make it clearer. You can have a look at this in a graph view, and again you can click through. You can look at strong acid, weak acid, strong base, weak base, and you can look at what happens to the concentration of the different ions and molecules there. Okay, we can change the tool that we're using. Instead of a pH probe, we could use some litmus paper, or we could see if it conducts electricity. So let's go back to the molecule view, and we can move, or there we go. We can use our solution to complete our circuit and see if it conducts electricity. Okay. See, strong acids a bit, water not so good. So it just lets you play around with some different concepts there. So this is the introduction. You can look at some preset examples there, but you also have the My solution down the bottom here. Again, you can use the pH probe, you can use the litmus paper, you can see if it conducts electricity, but on this one you have a lot more control. So you can set your own concentration. You can do that using the slider here or by clicking. You can change the strength, or you can slide it and make it a bit stronger, a bit weaker. Again, you can choose to show or hide the solvent molecules, look at it in graph view, or you can just hide it all and just test the pH. Okay, so there's lots of different options there. So the idea behind these simulations is it gives you a chance to explore, gives you a chance to change things and see what happens, and you can look at your own understanding of it and say maybe it's going to make you question it. And, well, I didn't expect it to do that. I didn't expect it to be able to conduct. Maybe think about why it might be able to do that. So that's the PhET simulations. Like I said, there's lots more of them on there. You can look at the pH scale. There's a build that's suitable for younger students there, but you can look at things on that one such as the electronic structure, look at ion formation and stability of ions as well. So there's lots of different things you can do, and there's a Beer's Law one as well. Okay, so that's the PhET simulations. Okay. So we also have a resource called Gridlocks. Now, Gridlocks, for those of you who like Sudoku, you'll be very good at this quite quickly, I think, because it's based on the ideas behind Sudoku, but with a chemistry twist. Okay, so you can come to this page here and you can see, depending what age group you fall into, there are a large number of Gridlocks that you can choose to use here, okay, and they're sorted by topic. Okay, so we're going to have a look at the acids one, first of all, from the 14 to 16 age range. Okay, we'll start the game. So to start off with Gridlocks, you have to complete a table. So this is about matching up information. So you've got, in this example here, we've got the name of the acid, the formula, and the salt formed when that acid reacts with sodium hydroxide. And you can see here, I'm on the time limit, and I've only got 3 lives. But I can get some hints if I need them. Okay, so I'm going to try and match them up. Now, I'm going to fess up and tell you I've got the answers here so that we can get through to the different levels. But what I'm going to ask some of you to do on the next level is to use the comment box to tell me what you think the answer is. Okay, so we're matching up the acids names, so we've got hydrochloric acid to go in here, we're going to match up nitric acid and sulfuric acid, and ethanoic acid will react with sodium hydroxide to make sodium ethanoate, and there we go, last answer. So then I can check my answer. So I've unlocked the next grid. But that table that I've put together is available for me to refer to here. So I can always come back to this. So this is where the Gridlocks isn't just focusing on you remembering something, memorizing it. It's helping with your understanding of how these things are linked together, because you can refer back to that. You don't have to have memorized it. Okay, but it's going to help you to be more fluent with these things as well. Okay, so now it becomes like Sudoku. So it tells you here, so we're focusing on the first 4 acids listed in the table. So in this box here, where we're looking at the name of the acid, all 4 acids are going to end up in here. Okay, so we've got nitric acid, so let's pull that over. Now, I know that the nitric acid can't go here, or this one here either, because this is the formula for nitric acid. So I know it can't go there, so I'm going to pop it over here. So you can see the idea when we can pull the things in. So then if I pull over the other formula for nitric acid, well, I know it can't go in this box because it's already in there. I know it can't go here or here because it's already on this row, so it's going to have to go up here. So you complete this one like you would a Sudoku. So I'm going to fill it in now. Like I said, I'm going to cheat, and I've got the answers in front of me so that we can skip through and we can show you some of the later levels. Okay, but you get the idea. So it's quite nice if you want to get more familiar, you want to get more fluent with matching up the acid names and the formulas. And then the later level, we're also going to look at how it matches up to the salt that it makes when it reacts with sodium hydroxide. Okay, hydrochloric acid. We can fill it in. Okay, so I've got the last one. Scroll down, it's at the bottom. Okay, so I've unlocked the next grid. So you can see then the next level, it's not just looking at the formula anymore, we're looking at the salt that's formed with sodium hydroxide. So you can see the idea of that one there. If I get stuck, remember, you can get a hint. You only get 3, so you don't want to use them too quickly, but you can see it's filled one in for me there. So if I'm finding it a bit difficult, I can do that. And if I can't remember, I can always go back and refer to my tables. That information is always available to you. Okay, so we're going to have a look at this one now. So this is for those of you who are looking at slightly older levels there. So we're going to have a look at the alcohol one. Okay, so we're on the timer here. Can anybody tell me the answer for this one here? So I'll start filling in the top row. But if you can tell me the answer for this one here, so what's the structural formula that's going to match propan-1-ol? Okay, and I'll start filling in the rest of it. Any answers? I'm going to have to answer it myself. No, none of you? Okay, well, we'll fill it in. That's fine. Okay. Okay, so we've unlocked the next grid. So in this one then, I'm going to match up, again, the same thing. I'm going to match up the alcohol to the structural formula. And what happens on this one is it gets a bit more complicated. Is when I get to the next level, each of the 4 boxes is going to be a bit different. So you're not just matching up the name to the structural formula anymore. You'll have the name, the structural formula, and the bottom left it becomes the type of alcohol, so is it primary, secondary or tertiary, and then the full oxidation product. So it's just making it a bit more complex. Okay, so that's grid locks. They're really great for some revision, for consolidating your knowledge, deepening your knowledge of particular topics. And like you saw on this page here, there are a lot of different ones that you can choose from. If you can't choose, you can just click on the play random game. Okay. Right, so we've looked at fit, we've looked at grid locks. Now we're going to look at our periodic table. So our periodic table is a resource that is going to be useful to you no matter what level you're studying at. So this is the main page here. So each element you can hover over and you can find out a little bit of key information here. So you can see the key data coming up in the middle. If you want to find out more, you can click in and you're going to get a lot of information about each element once you click into this particular page. Okay, so you can expand these boxes and you can find out about uses and properties, atomic data, which might be very useful for those of you studying A-level, supply risk, oxidation states and isotopes, again, very useful data. And then more interesting information as well for you, the history of it. There are podcasts about each element, there's little videos as well, and then there's resources linked to Learn Chemistry, so you can find other resources related to that element as well. Okay. But other things you can do on here is you can choose a particular block to highlight. So if you want to look at S, P, D or F block, if you want to look at a particular period or group on the periodic table, or you want to split it into metals and non-metals, then you can click all of these things here. Something else, you can change the temperature and you can see what happens. You've got a history tab, which is extremely interesting, and an alchemy tab as well. Like I said, you've got podcasts and videos, but what you might find more useful is the trends tab here. Okay, so just taking a little second to load on your screen, I think. We just got a little delay. Okay, and what you can do here is you can look at different trends. So you've got density, and you can see it really visually displayed across the periodic table. So if you're struggling to get your head around some of these trends and what they mean, then having a look at this might just help to make it a bit more visual, help you understand it, look at it from a different perspective. Okay, so we've got electronegativity, melting point, boiling point, and first ionization energy, all on the trends as well. So that's the periodic table. Now, the periodic table is online already, you can access this right now. But what we are launching this year, this summer, is an app version of this periodic table as well. That will be free as well. You'll be able to download it to your device, and then you'll be able to access this information offline as well. Okay, so keep your eyes peeled for that. I'm sure that will be announced in ChemNet when it comes available. Okay, so that's our problem. That's our periodic table, rather. Okay, so now I'm going to show you something called Oil Strike. Here it is. Oil Strike is an example of a type of digital resource where we've used gamification. So you might have seen some of these before. So digital resources can range from e-books, which are perhaps direct replacements for your textbooks, where you're accessing it online or using a disk instead of having a physical textbook. They can be interactive things like the PhET simulations that we saw. They can be videos or animations, or they could be educational games, and this is an example that falls under that category. So I'm just going to try and zoom in a little, just to make it a bit bigger for your screens. Okay, so in this one, so this is looking at fractional distillation. So this is for those of you studying at sort of GCSE or standard grade level. Or sorry, oh, I don't think you guys can hear the sound, so I'll just mute them. But you can see the text here. So you are the new Managing Director of Oil Strike, which is an oil exploration company. You have an oil refinery already set up in Southampton, and your mission now is to set up oil rigs at different parts of the world, so start bringing in the oil and making the money. So you might think, well, where does any of the education come into this? Okay, so where that comes into it is by answering questions correctly, you're going to get discounts on what you're doing here. Okay, so you can find out more information about finding oil and setting up oil rigs, and that's going to help you when it comes to answering your questions and setting up your oil rigs in the game. Okay, so there's lots of information here. Okay, and then when you want to conduct a survey, that's going to cost you this value here, but you can get a discount if you answer the question correctly. Okay, so it says here, which alkane is a major constituent of petrol? I wonder if we can get anyone to answer this time using your comment box. Okay, anyone? Okay, we've got some octane answers coming in there. So let's see, so the answer is correct, you've negotiated a discount. Oh, everyone's saying octane, good, good. Okay, so you've negotiated a discount there, so you're going to get your survey at a discount. Oh, we didn't find oil though, so that's unfortunate. So we can choose somewhere else. It does, I've played it a few times and it does do it randomly. So we've got chance of oil here in the Gulf states. It says 100%, so let's conduct the survey there. Okay, so all alkanes apart from methane, so let's see if we can get some answers again. So all alkanes apart from methane are unsaturated, contain only single carbon-carbon bonds, or contain a carbon-carbon double bond, or carbon-carbon triple bond. Can we get some answers? Oh, okay, so only single carbon-carbon bonds, that's the first answer up, so we're going to go with that one. Okay, correct answer. So again, you've negotiated the discount here. Aha, and we found oil. Okay, so we get 7.5 million barrels a month. So actually this seems quite good. So next step then we can build an oil rig. So we can choose if we want to build a concrete platform or a floating platform. So if we don't know what that is, we can click on the information and we can find out more, and that can help us to make a decision about what type of platform we're going to build. Okay, so let's just go for a concrete platform. Let's see if we can get a discount here. What is the best description of a hydrocarbon? Is it a carbon compound, a compound containing carbon and hydrogen, a compound of carbon and hydrogen only, or an organic compound? Okay, so we've got some answers coming up there. Containing hydrogen and carbon only. Your chemistry teachers would be very proud. Oh, sorry, I clicked the wrong one though. Okay, so we didn't get a discount there. Okay, so then we look at transport. Okay, so an oil refinery separates crude oil into saleable products. What's the name of the process that separates crude oil? This is an easy one. Who's going to get the answer up first? There we go, Michael, fractional distillation. I'll click the right one this time. We got a discount. Okay, so you can see you're answering some little questions here, but it's also a bit of a game. So that's the end of our first month, and then you have to complete a task. If you complete it correctly, we're going to increase the amount of oil we refine and make a larger profit. Okay, so this is our first task here, and so all you have to do is line these things up. Okay, so you can fill this in. You can see it gives you some little clues here with the little pictures as well. So shall we get some? Oh no, it's not even going to let me get it wrong. You just drag them down. Okay. Okay, so you can see you're working through it. It's a game. You're trying to make lots of money. There we go. We've made £51 million this month. Wouldn't that be nice? Okay, so that's the idea of Oil Strike. You work through it. It's fun. It's randomized, so you don't get the same questions every time that you do it. So you can play it again and again. It's going to help you cover some really key parts of fractional distillation topic there, and help you to get more familiar with it and deepen your understanding and your knowledge of that particular topic. And also, hopefully, it's pretty fun and engaging. Okay, so that's Oil Strike. Right, now we're going to look at a couple. Well, we're going to look at the problem-solving tutor first of all. Now, the problem-solving tutor is designed to help you with problem-solving skills in quantitative chemistry, and this is suitable for students who are at the top end of their national studies or their GCSE studies, or beginning of their A-level or higher studies as well. Okay, so the tutor is looking to teach you 3 different ways of solving problems. So the first one is knowing what you know and don't know. The second is tabulating the information, and the third is storyboarding. Okay, so we're going to look first of all at knowing what you know and don't know. And the aim of this activity is modelling the processes that go on in your brain when you're solving these types of problems. Now, what happens in my experience with students is when you come to a question, and maybe when you first look at it, it looks particularly tricky, and there can be a bit of a panic moment. I used to get this when I was a student as well, and I wouldn't really think through the question. I would just try and think of the equation that I knew was the right equation, and I'd put the numbers in, and if I wasn't getting the right number, you know, it's maybe get me a little bit stressed in an exam. So what we're trying to do here is take you through it step by step and break the question down and show you a method of just working through it in a really logical way that's going to help you to get to the end result and find out what it is you want to find out. So you've got the instructions here. If you close them and you want them back, you can always bring them back up by clicking this little button up here. If you want to go back to the home page, you want to try a different question, you've got a little button hiding under there, okay? So this question here is asking you to calculate the concentration of sulfuric acid in moles per decimeter cubed. It says it right at the end of the question here. And it's giving you some information in order to help you do that. And what the problem-solving tutor is asking you to do is to break that information down. So it's saying, well, what do you know now? What information do you have already from the question? Okay, and that's what you're going to drop into these areas here. And what is it that you've been asked for? Yeah, what's the question asking you to work out? Okay, so can somebody tell me what is the question asking me to work out? Looking at these options up the top, what one should I drag into the what have I been asked for? Oh, we had lots of nice answers before. Is this one a bit trickier? There we go, someone's answered. So the concentration of sulfuric acid. So here we go. So we'll drop this one down here. Okay, and let's saying what do I know now. So for that I'm going to have to consult my question. I'm not going to go through each of these asking you for the answers because we'd be here for the rest of our webinar doing that. So I'll just talk you through it. Okay, so it's asking you to drop in what do you know now. Okay, now I'm going to purposely get one wrong here, okay, because there's some information that I know and it's told me that the indicator is methyl orange. So I'm going to drop that in here. So I know that. I'm going to submit it. Okay, it's telling me that I'm wrong, but it's not just going to leave it at that. It's going to tell me a little bit about why I'm wrong. Okay, the idea is it's a tutor, it's a tutorial, it's working you through it step by step. It's not a right or wrong tick cross, you scored 4 out of 8. It's not going to be like that. It's going to work through it step by step. So it's telling me I've put information into the what I know now that isn't going to be used to answer the question. So while I was right that I do know this, I know the indicator is methyl orange, it's not relevant to answering the question. So I'm going to drag over the relevant information. Okay? And then it's going to ask me to put the irrelevant information in the bin. So I can pop that in there. Okay, so what it's saying now is, okay, so that's what you know now, and that's what you've been asked to work out. You can't get there straight away, but what can you immediately work out? So from this information, I already have what can I immediately calculate. So I have the volume of sodium hydroxide and I have the concentration of sodium hydroxide. So I know then that I can work out the number of moles of sodium hydroxide. So I can submit that. Okay, and then it's going to ask me for the calculation, and to get to that I'm going to use the numbers that it's told me in the question here. Okay, so we're not going to work through every step, but you can see the idea. You calculate that and then it's going to take you through the next step and the next step until you get to the answer to the question and you know what the concentration of sulfuric acid is. Okay, and you can see down the bottom here roughly how far through the question you are. So you can say, okay, well I've only got 6 more steps to get to the end of this question. So if we go back here, you can see that there's 6 of these questions and knowing what you know and don't know, so you can get quite a lot of practice at them. Tabulating the information is a little bit different, and this works well for those of you who are quite logically minded. You like to see things laid out in front of you. So you've got some precursor questions here. So the single product from the complete combustion of carbon is CO2, so just skip through this one and choose the numbers from the scroll option bar to give the correct mole ratio, which is a 1:1:1. And the main part of these questions is about breaking the information in the question down into this table format. And then it's going to take you through and work through it logically step by step. Now one thing to watch out for here is you've got some different options that you can choose. So that's not in this stage, but in one of the later stages you can choose, you could have chose, like, say for example 12 or 12.0, so you just have to be careful about your decimal places once you get further into your calculations. So that's something to watch out for whenever you're doing these sort of calculation problems, and the problem solving tutor will help you to pick up if you're rounding too much or you're using too many significant figures. So that's the tabulating information. The storyboarding information is a method that you may not have used before for solving these types of calculation problems. And I think sometimes what happens when we have these kind of complicated calculation problems is we can really easily forget what it is that's being described, and we think, oh, I just need to get the numbers and I need to put them into an equation and find out what the answer is. So what we're trying to help you do here in the problem solving tutor is make the connection again between the numbers and what the question's describing. Okay, because if you think about what's being described here, this would be something that you could do in the lab. So it's saying 10 centimeters cubed of hydrochloric acid of unknown concentration was put into a 250 centimeter cube volumetric flask. So what would that actually mean? Well, I would need a pipette, and I would need to pipette that into a volumetric flask. Okay, and then it goes to the next stage, and it's saying 25 centimeters cubed was required, of this diluted hydrochloric acid required 19.8 centimeters cubed of 0.1 molar decimeter per decimeter cubed sodium hydroxide. So again, I need to pipette that, and I'm going to pipette it into a conical flask. Okay, so I'm going to submit that. So then it's going to ask me to label what's happening at each stage. Okay, so we've got different options here. So you can see an example here. So you've got sodium hydroxide was added to reach the end point, this first lozenge here, or 19.8 centimeters cubed of sodium hydroxide added to reach the end point. So these are both saying the same thing. They're both correct statements, but you can see that one of the answers is better than the other. Okay, so I'm going to make sure that I choose the best answer when I'm choosing my answers. So I label each stage and I submit that, and then it's going to ask me to calculate each stage of this question until I get to the end result and I've calculated the concentration of the original hydrochloric acid. So it's just breaking it down in quite a different way. It's quite visual. Particularly if you're very skilled at practicals, that you might find that quite easy. If you're not, you might find this really helpful way of thinking about it. And what you can do here is you can download some PDF examples. So if you think, okay, well, I actually really like that method of solving these problems, and I want to try that outside of the computer to see if I could use that method in real life if I was doing a practical or if I was doing a question in an exam, then you can print these out and you can try this method outside of the computer. Okay, so that's the problem solving tutor. As you go from left to right, so these questions start off the easiest, getting harder through storyboarding. So you can start at the left. It tells you there, start off at the left and work your way through, and the questions get progressively more difficult. Okay, so that's the problem solving tutor. The last thing I want to show you very briefly is our aspirin screen experiment. So this is something that you would use in conjunction with the aspirin synthesis practical. Those of you studying chemistry at a higher level have perhaps already done, or perhaps you know that it's something that's going to be coming up. So this can help you with that practical work in class. So you can choose to register and set up an account, and that way it remembers how you got on and you can come back to it last time, or you can just quick start and you can have a little look, okay? But this way it's not going to remember where I got to. Is it loading? It's taking a little minute. I might have to ditch that one. I've got some screenshots of this one if it's not going to work. Okay, let's try. Okay, I'll just show you some screenshots of that one because it doesn't seem to want to work. I think it's probably my internet connection is not fast enough here. Okay, so the aspirin screen experiment, you can do a quick start. It's going to ask you some questions. So here it's looking at the different numbers of atoms and the different compounds that are taking part in the reaction. So you can get points for answering each of the different parts of the level correctly. And then it's going to get you to a point where you can put together the practical equipment and you can try it out. So you could try having a heating mantle or a Bunsen burner. You can try it using a conical flask rather than a round bottom flask and see what happens. You've got a small flask here, so you can see, oh, maybe that's not going to work out. It's going to be a little bit too small and your liquid's going to overflow. So you can play around with these different things so that when you get into the lab and you're doing the practical with your teacher, or perhaps you've done that practical but you want to refresh your memory about it, then you can play around with it on here. And it just highlights some of the common errors that are made during practical activities, so you can make sure that you avoid them when you do your practical. Okay, so that is everything that I wanted to demonstrate to you today. So what I want to do now is just to try and get some of you on the microphone to tell us what you think about what we've shown you, and also maybe to tell us about some other resources that you have used and that you found useful. Or maybe you just have some other related thoughts about using online resources perhaps it relates to some of the pros and cons that we talked about. So I think some of you have been volunteering while we've been talking, so we're going to get a couple of you on to speak. So who do we have first, Tanika? Michael. Okay, so we're going to get Michael on first. I think we might have unmuted you. Michael, are you there?
I think so, yeah.
Yeah, I get you. You're a little quiet, so you might need to speak up a little bit, but I can hear you. Okay, Michael, so what did you want to share with us?
Well, firstly, I thought all of them were really good things. I'm kind of interested in the alchemy side of things on the periodic table page right there. But,
Good.
also, has anyone ever thought of sort of like doing one where it's not to like say an app or a website where it's like sort of a virtual version of say a school lab, and depending on what level you are, you can do your own experiments. Say like you've got all the ones that I'll show you, was that a bit too similar to history?
So do you mean you could select your solutions and you could select your reagents and glassware and just make it up and see what happened?
Yeah, that kind of thing.
Yeah, that sounds like a great idea. It's not something that we're working on at the minute, but it does sound fascinating. I'd love to play around with it. We are working on more of the practical ones, like the aspirin synthesis that you saw. We're working on one right now that's called titrations, so it's going to be about looking at how to carry out a titration. But that sort of exploratory side of it, that sounds really interesting. If anyone does come across something like that, we'd love to hear about it, because I'm sure that would be really useful. But I'll pass that on to my colleague who looks after our experimentation work. I don't know if that's something he's looking into in particular, but perhaps he can get back to you specifically about that. What would you like to do with it, Michael? What would you see as being the benefit?
It's more the fact that instead of just being shown through it by teachers and stuff, they can actually come up with what's going on themselves and try and understand what they're doing with their own devices.
Okay. Oh yeah. Okay. So I think I understand. So maybe something like what we've got, but a bit more chance for you to try it yourself without being necessarily led through it so much.
Yeah.
Yeah. Okay. That sounds really interesting. I like that idea. Okay. That's great. Is there anything else you want to add, Michael?
No, that's about it.
That's great. Thank you very much. Okay. Right. Well, our other volunteer is Alex. So I think we're going to unmute Alex now. Alex, are you there?
Yeah. Can you hear me?
Yeah, I can hear you really clear. Okay, great. Alex, what did you want to share with us?
Well, the first one was the periodic table of videos project by the University of Nottingham. I think it's a great resource for GCSE students and for general interest, and it's great for boosting your enthusiasm for the knowledge of chemistry.
Yes, they're great, aren't they?
And then a bit more tailored towards the educational needs would be Quizlets. Quizlet is an app and a website where you can put all of the definitions that you need to learn in, and it'll create quizzes based upon them to test your knowledge and understanding of what you need to know. And the fact that it's tailored to everyone's individual course because you're putting in your own terms makes it a good resource for exams.
So you can just put in any questions that you like in there?
Yeah, so you could go through the specification of your exam board and put down all of the key terms and definitions, and then you can have it as an app or online, and it'll just create different ways of learning it. So it might ask you questions on it, it might create a card game based upon it, or things like this.
Okay, that sounds good. I've seen different flashcard apps. I mean, flashcards are really traditional way of learning information when you've got a lot to learn, which you do when it comes to your exams. Yeah, and these digital ones can be really great because you don't have to have lots of different postcards that you carry about with you. You can just have it on your phone in your pocket. And so yeah, Quizlet sounds like a great example of one of those apps that are available.
Yeah. Also, the Royal Society of Chemistry has the spectroscopy in the suitcase, which there's some resources online. You just search it into Google, and they've got a great introduction to spectroscopy and spectrometry, which is great for the A-level courses.
Yeah, there's some really great stuff on there. So Learn Chemistry is a really good starting point. So a lot of the resources on there are ours. The Royal Society of Chemistries, but there's also other people's resources on there where there's other good things going on online, and we like to be able to point people to those as well. So yeah, it's great that you've picked out one that you find on there, Alex. Okay, is there anything else you wanted to add?
No, that's it. Thank you.
Okay, great. Thanks for coming on the microphone. That's great. Okay, we're going to pop you back on mute there. Okay, great. So I think that's probably all we've got time for in terms of, have we got one more person? Okay, yeah, I think we'll fit one more person in. Okay, so who do we have now? Nicole? Okay, right, so we're going to unmute Nicole now. Are you there?
Hiya.
Hi, Nicole. Yeah,
Hi.
I can hear you.
I think this webinar is really good. The titration simulation thing, I've used that. It's really good for like seeing how to do spectroscopy and stuff. Not spectroscopy, chromatography, because you haven't been able to do it at school. So it's been really, really good. There's an app called ChemNet's which allows you to experiment with different equipment and different types of chemicals, and you can, that's kind of like what Michael explained, I think.
Okay, well that sounds really interesting. What's that called? Chemist?
ChemNet's, yeah.
Okay, that's great. We'll have to have a look at that one and see what that's like, but it sounds really good. So what do you do with it, Nicole? How do you use it?
I use it to kind of experiment with things that maybe I won't be allowed to do at school, or I just kind of, yeah, see what's going on. It's really good.
Okay, so you can just select the different reagents and select the
Yeah,
glassware.
like how much you want to put in and stuff, and you can say, I'm fine, you can do what you want.
Okay, that sounds really interesting. I think I might have a look at that once we're done here. Okay, thank you for coming on. Is there anything else you want to add?
No, thank you.
Okay, that's great. Thank you so much. Okay, so I think we are getting right towards the end of our time, and we want to do one more poll before we go. So that is just to find out how confident you are now. And then I'm just going to pop up my contact details in case any of you have questions that you think of later and you want to get in touch, okay? Although remember, you have that ChemNet forum, so you can just pop questions on there and share all these ideas, these other resources that you're coming up with as well. So the question is, how confident do you feel now finding and using online resources? And the options are the same as before. Are you very confident, confident, a bit confident, or not confident? Okay, so lots of you responding now. I think we're about done. I think we're going to close the poll now then. Okay, great, and show you the results. Okay, good. So hopefully we've helped some of you feel confident to go and get started. I mean, that might be with our resources, it might be with some of the other resources that other people have mentioned, or other things that you come across and can mention on ChemNet. Like I said, Learn Chemistry isn't just about Royal Society of Chemistry resources. There are other great resources on there as well, so you can always use that as a starting point. But if any of you come across anything fantastic, we always want to hear about other things on there that are great. So if we just pop back to the PowerPoint here, if we can do that. Yeah, so yeah, there we go. There's some contact details there. So we've got our Learn Chemistry inbox, which we do occasionally get emails from people like you guys asking us about our resources on Learn Chemistry. You also have your ChemNet resources. You've also got Gareth there helping you loads. If you've got anything specific about the webinar, feel free to contact me, but otherwise you can get in touch through the normal channels. Okay, thank you very much everyone for your time, especially as for a lot of you it's your Easter holidays. I hope you've had a really good holiday and you're all ready to go back to school, and all the exam season is coming up now. I wish you all the best of luck. One last thing just before we go is, remember, as Gareth mentioned, we've got Meet the Universities coming up. It's in London on the 20th of June, in Sheffield on the 27th of June. And this is a really fantastic event, a really great opportunity for you guys to come and meet people from lots of different universities. So get signed up for that. Okay, thank you very much. I think we're going to close out the webinar now. Okay, thank you. Bye.